Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Raihan bin Rasim. Today I would like to share with you about my final year projects, which is implementation of blockchain technology in IoT applications. So in this video, I will share to you how to create an Ethereum blockchain network. So in this project, I have created two nodes of Ethereum blockchain in two different devices, which is one first node in my laptop, second node in my PC, both in Windows. So for the first node, this is for the first node. First step, I have to create a node. So to create a node, I have choose to use the Go implement Ethereum client, which is called as GET, which is a platform to create and to run Ethereum blockchain. So first I will check whether the GET client have been installed or not in this PC. I run the command using this PowerShell, which is more powerful than CMD. So I will like to use this Windows PowerShell to run all those commands. First, I want to ensure that GET client is installed in this Windows. I have to just type GET version to know the version of GET installed in my Windows latest version. This is a version of GET that's been installed in my Windows 1914, which is the latest version that I have downloaded from the website, GET Ethereum website. So next step, I have to run GET server to create a first node in my Windows by just typing GET. And this is GET server. Once I have typed GET, the GET server is running. So node 1 has been created in this window. So I have to stop this server by press Ctrl C. Ethereum protocol stop, transaction full stop, blockchain also stop. For the next step, I have to do the mining process to mining the GET server. Mining is a process to create an Ether. In Ethereum, Ether is act as fuel to run the Ethereum blockchain. To create an Ether, I have to do the mining process, mining this GET server. To do mining, I have to just type GET mine. GET server has been mined. Update mining trades. Commit new mining work. This mining process also, I can stop it. So in this mining process, there is important information for start P2P networking. They have enode code, long hex string, long code. This long code, I will be use this code to connect to and interact to other nodes. This code will be used to interact and connect with other nodes. Later, I will be show you how this node will connect to other nodes. by using this long hex string. So the mining process is done. Get server has been mined by using this command gets mined. So other steps, I have to create a get new account for my get server. Just get account new. So we have to create a password, a strong password to access into our account, our get account. Again, same password. It will show us two main info that we must store and remember. First, there is public address of the key. This public address of the key is public address of code key we can use when we do the transaction of data between nodes, between other nodes. This key is important. So the address of key we can share with anyone, with any user, with any nodes they active to interact with each other. This key we will use to interact with each other. We can do data transaction, fund transaction using this key. Other nodes have different public address of key, but you must never share the secret key. This below of the public address is the secret key file, which is stored in this directory, file directory, etc. This is the date, and this is the secret key. This secret key is the key control access to our funds, our data. This key we must not share with others. If we share with others, others will take your data or funds easily using this key. And you must remember the password. If you lost the password, you cannot enter this account. You must create a new. So for the next step, I want to create an Ethereum node in node 2 using my PC. So first of all, I have to check whether the get client, Go Ethereum client is installed yet or not in this PC by typing get version. This is same as Node 1. Get version also the latest version 1.14 is stable. This is shown that gets has been installed in Windows in my PC. So for the next step, I have to run get server, same as at Node 1. So this is get server that have been running. By running this get server, our second get node is created. I've done created. So I have to stop this server from running. Transaction post stop, virgin stop. So the server is stopped. Next step, I have to mine again. Mine for get node 2, also same as get node 1 mining process. So I have to mine get for node 2. I just stop first this mining process. So this mining process for node 2, at start P2P networking, there is some long hex string inode code. This long code I will be used for the next step, the next process to connect between node 2 and node 1. I will be copy this to the notepad to transfer to the node 1 to connect and interact each other. We will do I will be do that later. So next step, I have to do get new account. Let's type get account. Save. We put our password to fill out the password. Access the get account for node 2. You can so when the new key was generated in get node 2, this is my public address key for node 2. We will use this. This is different address compared to node 1. Different nodes, different public address of the key. We will use this address to do data transaction between other nodes. Below of it is part of the secret key. The secret key is located in this file directory of Ethereum. This is secret key. We must not share with other nodes or other users. Due to this is key that control access to our funds. Same as node 1, I have explained earlier about that. So this password for our get account node 2 also you must enable. So that's all. So after I have created two nodes into two different devices, the next step we want to connect each other, connect between two nodes. We want to create connections between those two nodes, these two nodes. So at first, I have to get the data for get node 1. I will show you the data which is stored in the file in get Ethereum. So I run this command. Data1 is the name of the file that will contains all the data of get node 1, all important information and details installed in there. And ID for the system which is fixed. Then that console. So you will see get start in dev mode. Many of data have been shown here. Address, database, this is JavaScript console. I have opened JavaScript console to run a command which will interact and connect to other nodes. If I run this command, this is my get node 1, and we want to connect with get node 2 by running this command. Just type admin.su, and this column we will fill it with enode. inode for inode of get nodes 2. I have been copied in notepad. This inode after mining process that I have get in mining process of get nodes 2. If not, I have to copy this inode of get nodes 2, copy in this nodes hex string code for nodes 2, copy in nodes 1 to add here to connect and interact each other. Close. Then F2. So the connection has been created between node 1 and node 2. So it is done to connect each other. Run the commands for do the data transactions due to some error in the Windows system that I can show you how I run the command, but it's okay. I will show you how this transaction will be created between those two nodes. I have to refer to this website that will show how to do the data transaction or fund transaction between nodes using GETS client, Go Ethereum client. These commands we will use this command get attached. This command in my Windows cannot run. They will go out some error. Due to that error, I have researched to the error. Many people or users has complained about that error, but it cannot be solved yet now. So I cannot move to this step to this command. I will show you how this command works. This command get attached this in the name of the file for get command. We cannot come out the arrow button, and we can run this command add.send transaction. This command for the data transaction add.send transaction from this address. If this is a public key address that I have shown you earlier, from when we create a get new account, we have get the public key address. This public key address is used for data transaction. And this is from, as an example, we want to do data transaction from nodes 1 to nodes 2. This is public key address for nodes 1, for 2, and this is public key address for node 2. You have to copy the public address, insert into this command. And this is a value, how many of the value that we want to transfer, fund and data we want to transfer. Value is depend on you. In Ethereum, there is many kind of currency we can use. So after run this command, it will go out like this. This is an example that there have been run this transaction. It will come out with one hex string code. This is a transaction hash receipt. This is called as transaction hash receipt. That shows us the transaction has been succeed. So the data transaction has been succeed. Then we also can check our balance in our balance in our account by use same command like earlier, and we can type s.getBalance, and this our public key address, and we enter, and it will go out our balance after we have do some transaction, data transaction or fund transaction. It will go out our balance in our account that have left after we do the transactions. Okay, that's all for transaction. You can do, and you can try it in your Windows. So the last show you the simulation, because my Ethereum network is called small scale private Ethereum network. All of this simulation, our simulator, just use on large scale of network, like the nodes all over throughout the world. And in Windows, just use only two nodes, very small network, cannot be efficient to do this simulator. So I will show you two types of simulator or simulation that have been used to testing and analyze the blockchain network. First is called as SimBlock. SimBlock, which is an open source blockchain network developed by Japan company. This SimBlock also this suitable for use in blockchain network research. If you want to do some research on blockchain network, suitable to use this simulator. It also has a visualization tool, which we can see transition of block propagation. And this throughout the world, throughout the country. This the color nodes is shown us is the nodes of the user throughout the world. All the nodes, we can see the data, transition of data and block propagations by using this visualization tool developed by SimBlock company. And we can download this visualizer and the simulator from here, and we can use it. We can also use online visualizer. That's all from SimBlock. Detailed explanation. Another simulator I've been read is Vibes. It called Vibe simulation, which is fast blockchain simulator for large scale. This used for large scale only, large scale peer-to-peer networks. This Vibe simulator user can explore characteristic and metric of this blockchain network, and can investigate the interaction among those nodes, among users. So I will show you some part of simulation result doing by this Vibe simulations. So this simulation results, and they will also show you block transfer from one node to one node at what time. All this kind of details can be simulated and visualized using this simulator. You also can read the length of the blockchain network, average block per time, total number of nodes in one network. All these data will be given, will be shown in this simulation. Also, we can this result show us about how secure the blockchain is when we do some simulation attack. We do some simulation attack, successful. Attacker is successful at block. Which block we succeed to attack to do simulations? Block 4. Then this is probability of successful attack. Attack duration 20 blocks. This some attacks in this blockchain. When in this blockchain network, when we attack one blocks, the other blocks of code, or it's called as hash, will change, and the change will be invalid to do the data transaction. So other nodes, when we attack one blocks, other nodes or other blocks will know there is an attacks, an error will be go up, an error, and will be known. The attacker will be known after just attack one blocks. So it is time between blocks, time of data transaction, or time of block creations. This also show the transaction for each block, pending transactions. So many results that we can get from this simulation. So that's all from my projects.